Okay, 69 is a compound inequality. But this is easy, because the only thing you should do is adding 6 here. 6 and 6. S6 plus 0 is 6. 2x. This is cancel out this part, and it's a 10. Divided by 2. This is 3 less than or equal x, and 5 here. Okay, the graphic representation of this solution is, look, this is the all real number line, this is all real number, this is infinity, this is negative infinity, this is 0, 1, 2, 3, 4 and 5. Okay, the bunch of values in between 3 and 5 include both endpoint 3 and 5. Okay, now is in interval notation is bracket 3, 5. The set notation is the value of the x satisfies this condition. X between 3 and 5. That's it. Okay, 71. It's a compound inequality. Again, we're subtracting 4. Negative 9. Cancels out this part. Minus 3x. And this is minus 2. Finally, divided by negative 3. Minus 3. Minus 3. And remember, when you divide by negative, you're switching, you reverse this. This is 3 greater than or equal x greater than or equal 2 over 3. Okay, you leave it like that. Oh, much better, much better. You moving this guy to this, because I suppose it's the lower and this is the upper. And normally the lower you put in the left and the upper you put in the right, and when you interchange you must reverse it again. This is a more elegant solution. Okay, graphic representation of this solution is infinity, negative infinity. This is 0, this is 1, this is 2, this is 3. It's a bunch of value between 2 over 3. 2 over 3 is in between 0 and 1. You divide here. This is 2 over 3. 2 over 3 and 3. Include both. Bracket, bracket. Now, the interval notation is bracket 2 over 3, comma 3, bracket. Or inside notation is such that, and you copy that, 2 over 3 less than or equal x less than or equal 3. Okay, inequality again, 73. In this case we have a fraction and multiply by 4. Multiply by 4. The entire inequality is minus 12 less than 2x minus 1 divided, multiply by 4 cancels out, less than 0. So it's plus 1, plus 1, plus 1. It's a negative 11, less than 2x, cancels out this part, less than 1. Divided by 2, divided by 2, divided by 2. The answer is negative 11 over 2 less than x less than 1/2. And the graphic representation is, look, this is infinity minus infinity, this is 0, this is 1, 2, 3, 4, and 5, and 6. Okay, 11 over 5, and decimal is like a minus 5, 1/2. Because it's, yeah, perfect. Entonces it's a negative 6, it's a negative 5, 1/2 is here. So it's, and between this guy is negative 11 over 2, and this is 1/2. This is the interval between this and this. No include endpoint. This is parenthesis and parenthesis. And now the interval notation is parenthesis negative 11 over 2 comma 1/2, and the set notation is just x such that xn between negative 11 over 2 and 1/2. Okay, 75. I copy here. Let's see what happened. Well, let's compound inequality again. You're subtracting 1 here. This is 0. Is it cancel? It's negative 1/2. X less than 3. Okay, I want to eliminate this. You multiply by reciprocal. Reciprocal is minus 2. When you multiply by negative 2, whole thing, 0 times negative 2 is 0. This times this is just x, because the intention, because negative 1/2 times 2 is positive 1, and this is negative 6. 3 times negative 2, and you must reverse it again, the inequality sign. In order to write in elegant way, you put negative 6 here, 0 here, and you must reverse the inequality sign again. Okay, the solution interval is the interval suppose 0 here, 1, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6 here. As in between negative 6 and 0. Do not include both endpoints. And the interval notation is parenthesis negative 6 comma 0 parenthesis. And the set notation is just copy this, minus 6 less than x less than 0. Okay, 77, inequality again. You multiply here is FOIL, x squared minus 3x plus 2x minus 6 greater than, and multiplication this and this is x squared minus 1, because it's like a difference of a square. You express everything in a standard form, you're moving everything to the left. Minus 6 minus x squared plus 1 greater than 0. And you combine like term. When you combine like term, the quadratic term cancels out. And we have here minus x, minus 3 plus 2 is minus, and this is minus 6 and plus 1 is minus 5 greater than 0. This is minus x greater than 5 divided by negative 1. X is less than negative 5. Okay, so now the representation of this interval graphically is infinity, negative infinity. This is 0, 1, 2, 3, 4, 5, minus 5 here. This interval is less than, this is to the left, is this interval. Of course, do not include negative 5. Because the interval notation is from negative infinity, comma negative 5. And the set notation is x such that x less than negative 5. Okay, 79 is similar. Okay, you apply this derivative property here. Is 4x squared plus 3x less than or equal, and you expand here using quifoil. Remember guys, quifoil is a plus b squared is a squared plus twice ab plus b squared. I just square it first, 2x squared plus 2 times multiplication this times this is 2x times 1 plus 1 squared. This is 4x squared plus 3x less than or equal 4x squared again. The multiplication here is 4x plus 1. Okay, I put in standard. Everything to the left. Right hand side must be 0. Okay, combine like term. This is cancel out. Perfect. This is minus x plus 1. Less than or equal 0. Minus x less than or equal negative 1. Divided by negative 1 both sides. X is greater than or equal positive 1. The solution graphically or real number, this is 0, this is 1, this is 2, this is infinity positive, this is infinity negative, is greater than or equal 1. Entonces, this interval include 1 because it's equal. Then, in interval notation is bracket 1 comma infinity, and set notation is the x such that x is greater than or equal 1.